All right, here is your free response question of the day. So let f be the function defined by that. F at x equals e to the x times cosine x. And the first question is find the average rate of change of f on that interval. Well, that's the same as asking for the a rock. So let's see if we can do that. So there's enough room right here to answer that. So to find the a rock, what I need to do is find the slope between 0 and pi. So the numerator will be f at pi, subtract f at 0. The denominator is going to be just pi subtract 0. So if I just do some substituting in, so first of all, substitute pi in for x, that's e to the pi cosine pi, no need to simplify. Subtract, plug in 0, that's e to the 0 times cosine 0. And then divide all of that by just pi. Now, you could simplify it, but for this, you should just be done, take a picture, and so on. Now, if there's a need to simplify it with a question later on that connects back to it, then of course you can do that. All right, B, what is the slope of a line tangent? So what does that mean, slope tangent? Oh, and by the way, this is the real question used, number 5 for 2018. Slope tangent's another way of talking about the derivative at what value? At 3 pi over 2. So step 1 is to find the derivative. Let's see if I have room here. It's not going to take too much room. So if I'm going to take the derivative of f at x, that's going to be the product rule. That is the first times the derivative of the second, and the derivative of cosine is negative sine, plus the second times the derivative of the first. Now I'm going to substitute in. So what's the derivative at 3 pi over 2? I'm going to run out of room. I'm going to do that down here. So when I substitute in the derivative at 3 pi over 2, wherever there's an x, you plug in 3 pi over 2. No need to simplify. And you have your answer. Part C. We are moving along here. Again, this is the actual question used in 2018. Part C. It says, find the absolute minimum. So when I hear the word absolute minimum and I have an interval, I got to know that I need to know the ends, so the end values, as well as any critical numbers between them. So let's look through that first together. So I'm going to create a little table. So if I'm going to have this table in terms of find the absolute minimum value, and again, it's not going to be the x value, but the y value is the answer you're looking for. But we're going to start there with x and f at x. And I said, we're going to make sure we include the end. So I'm going to do that right away. These do not need to be in order. So 0 and 2 pi need to be a part of it. Then, when you take the derivative, and I already did that, so the derivative is e to the x negative sine x and cosine x e to the x. I'm going to make that equal to 0 and solve it. Now, I'm going to factor out e to the x, and I'll be left with cosine x subtract sine x. Now, e to the x could never equal 0. So you take each factor equal to 0. So if I take that, that will never equal 0. But if I take the second one and solve it, I'm going to add sine x to the other side. I'm looking for an angle where they're equal to each other. So at pi over 4, cosine and sine have the same value. But there's another place they have the same value, and that's at, not 3, but 5 pi over 4. They both are negative and the same. And that's in my interval between 0 and 2 pi. So I want to look at pi over 4 and I want to look at 5 pi over 4. So I'm looking at each one and I want to know what the y value is at each one. So when you plug in 0, what's the answer? Now I got to go back to the very beginning. Now for these, you might need to simplify it a little bit to know which one's going to give you the absolute minimum compared to something else. So if I plug in 0, and I'm going to write down the function again here, just to remind me, the beginning function was e to the x cosine x. That was it, not the derivative. So when I plug in 0, do I know my unit circle for each of these values for cosine? That's going to be the only challenging part. So for each of these at 0, 2 pi, and so on. Well, 0 and 2 pi will give you the exact same. Well, 0 and 2 pi will give you the same answer for cosine, but not for e part. So if I plug in 0, e to the 0 is 1. What's the value of cosine at 0? That's the x-coordinate at 0 degrees, or 0 radians, and that value is 1. So that's 1 times 1, which is 1. If I plug in 2 pi, you again get the value 1, but this is e to the 2 pi times 1. So e to the 2 pi is bigger than 1. So I already know that that can't be the right answer as an absolute minimum because that number is bigger than 1. Pi over 4, e to the pi over 4, and that's going to be the value of cosine at pi over 4, which is root 2 over 2. So if I put that together, e to the pi over 4 times, now let's put it right here, e to the pi over 4 times root 2 over 2. And then the last one is 5 pi over 4. Well, this one's going to be more interesting because I know the answer is negative root 2 over 2 times e to the pi over 4. So negative root 2 over 2 times e to the 5 pi over 4. Which one will give me the absolute minimum here? So it's only one that has actual negative value, right? So the question is, what is the absolute minimum value? So the absolute minimum value is negative root 2 over 2 times e to the 5 pi over 4. And that's it. Notice they're looking for the y-coordinate there, not the x-coordinate where it happens, but the actual minimum value. All right, part D, I'm going to run out of space, so I'm going to find a paper. Where did my paper go? Oh, up here. So the last one I'll do on a different piece of paper here. 3D. It says let g be a differentiable function such that g at pi over 2 equals 0. The graph of the derivative of g is shown below, and it says find this value, the limit as x approaches pi over 2 of f at x over g at x. So let's just start with the limit. So first of all, limit is a substitution question. So I have a feeling it's going to be L'Hopital's rule, but let's just make sure. So the limit as x approaches pi over 2 of f at x. Let's start there. So if I look at f at x and I put in pi over 2, the value of cosine at pi over 2, focus in here. Not going to focus on here. Oh, let's see if we can. There it is. When I plug in pi over 2 for cosine, that's the top of the unit circle. That's 0 for the x-coordinate. So the x-coordinate at pi over 2 is 0. So 0 times anything, that is going to equal 0. If I said, what's the limit as x approaches pi over 2 of g at x, this also needs to be 0 for it to be L'Hopital's rule. So let's remind yourself, it says the value at pi over 2 is equal to 0. I don't have to look at anything else. So clearly this is L'Hopital's rule, right? It's okay even to write it down for the people who are grading it. It's L'Hopital's rule clearly. So I'm going to write the limit again, but this time I'm going to take the derivative of the numerator and denominator. So it's the derivative and the derivative. And now let's try again. So now I'm going to separate them again. So I'm going to have the limit as x approaches pi over 2 of the numerator. So again, it's a substitution question, but I need to know what the derivative of f is. So we did that. So the derivative of that, I'm going to write it down. That was when we did the product rule. That's e to the pi over 2. I'm just plugging in what the x value is as I go along to the derivative. A negative sine pi over 2 and plus cosine pi over 2 and then e to the pi over 2. So I just did when we did the derivative in part B, I just plugged in, wherever there's an x value, I plugged in pi over 2. Recognize that the x-coordinate here of this is 0. So this is 0, and if I wanted to simplify it, that answer is 1. So it's negative 1 in that. So the answer is negative pi over 2. Unnecessary. You could just write that in the numerator. The denominator, the limit as x approaches pi over 2 of the derivative of g. That's when we're going to have to look off of here and figure out what the derivative is of g when it approaches pi over 2. So this is the derivative. Now, what they want you to be confused by is that there's a cusp. But what we're not looking for here is the derivative of the derivative. In other words, I'm not looking for the slope here. I'm just looking for the value it is. So at pi over 2, when you go from the left and the right, does it approach the same y value? And the answer is yes, it's 2. But they want you to think it's undefined because there's a cusp here, because you lose the understanding of what you're looking for. So we're not looking at the derivative of the derivative. So here's the graph of the derivative. Approaching from the left and from the right, does it give you the same answer? And the answer is yes. So the derivative there at pi over 2 is 2. And then to put it all together, here, back here, you could just copy this or simplify it over 2. And you answered the question. All right, you are done. Thank you for doing your work with me. Mr. G Math, over and out. Until next time.